Right, so in this video I'm going to have a look at finding the equation of the tangent to a curve. So I'm going to do two examples, one fairly straightforward one and one involving implicit differentiation. So let's have a look at number one here. I'm just going to have a look at this particular equation here. Let's take y is equal to 3 plus 2x minus x squared. And we're going to have a look at finding the equation of the tangent to this curve at the point, let's say 2, 3. So this is a quadratic function here. It's going to look something like this, and somewhere along here you'll have a point, and that point will be 2, 3. X is 2, y is 3, and we're going to have a tangent here, so that will come down along this way roughly. So it'll look something like that. Now let's start anyway. So what we're going to do is, first of all, we're going to differentiate this function here. So we're going to take dy dx, and the reason we're going to do that is because in order to find the equation of this straight line here, we're going to need the slope of this straight line. So in order to find the slope, we need to differentiate this function here, which will give us 0 for 3, it'll give us 2 for the 2x, and minus 2x for the x minus x squared here. So this here will give us the slope of the tangent at any point x. Now we want the slope of the tangent at a point where x is equal to 2. So the slope, or m if you like, of this particular tangent here is going to be this here, and we just replace the x with 2. So it's going to be 2 minus 2 times 2. So that will give us 2 minus 4, which is minus 2. So the slope of this particular tangent here is minus 2. So now we have the slope. So all we need to find the equation of this particular line here is a point and the slope. We have the slope, we have a point, so let's just do that then. So we're going to just write down the equation for a straight line is just going to be y minus y1 is equal to m times x minus x1. Now, so we just stick in our numbers here. We know that our slope is minus 2, and our point again is 2, 3. Point is 2, 3, so we have 2, 3 as our point, and we have our slope as minus 2. So we'll just put these in. So we've got y minus 3, that's our y1, is equal to minus 2, x minus, our x here is 2. So this is the equation of our tangent. So let's just tidy this up a little bit. That will give us y minus 3 is equal to minus 2x plus 4. Okay, let's just take these two. We'll bring these two over here just to tidy it up again. So we put the 2x first. We've got our plus y. We've got a minus 3. And when we bring this over, it'll be minus 4, subtract 4 from either side, so that will be minus 7 equal to 0. So this now is the equation of our tangent. So this is one of the applications that we can use differentiation for. So let's do another one, slightly more complicated, but not too difficult. So we're going to take another equation. Let's take this one here. This is second one. So let's take y cubed minus xy minus 6x cubed, and we'll say that's equal to 0, and we're going to find the equation of the tangent to this particular curve at the point 1, 2. So again, we've got to differentiate this in order to find the slope. Remember, a tangent is a straight line. In order to find the equation of a straight line, we need to use y minus y1 is equal to m into x minus x1. So we need a point, which we have, and we need the slope as well. So to find the slope, we need to differentiate this particular function here. Now, we're going to have to differentiate this implicitly. So I'm going to take the y cubed first, and differentiate that. So we need to use the chain rule here, so that's just simply going to be y3, let's say 3y squared, so we differentiate the thing as a whole first of all, bring the 3 down, write down the y and then subtract 1. Now we've got to differentiate the y part of it, so that's just simply going to be dy dx. We don't know what y is exactly, so just write down dy dx. Now we've got to differentiate this here, so I'm going to put that in brackets here. I'll leave the minus outside here and I'll just differentiate the xy. Now the xy here is a product. You're multiplying the x, function of x here, with another function of x here, but in the form of y if you like. So we're multiplying x by y, so we need to differentiate this using the product rule. The product rule is u dv dx plus v du dx. So let's call the x or u, and let's call the v, the y here the v. Okay, so we're going to use u dv dx plus v du dx. So that's what we're going to use here. So let's do that then. Okay, so we need to write down u, which is x, and now we need to differentiate v, which is y, so we don't know what y is exactly, so we're just going to write down dy dx plus v, which is y, and now we differentiate u. U is x, so if we differentiate x we just get 1. Okay, so that's that bit done. Now we need to differentiate this term here, so that's just going to give us minus 3 6s 18 x, and then subtract 1 from the 3, so we get 2, and that is equal to 0. If we differentiate 0 we get 0. Okay, so now we have it. Now what we need to try and do here is try and isolate the dy dx. In other words, get dy dx equal to something. So we have two dy dx's here, so we need to get those together and then factorize. So let's do that. Let's get rid of these brackets here first. So we have 3y squared dy dx minus x dy dx minus, remember minus times plus is minus, y here, and then we have minus 18x squared, and all that is equal to 0. Okay, so let's see, we have a dy dx here and a dy dx here, so I'm going to take those outside the bracket, dy dx, I'm just going to factorize these two terms here. Here I'll be left with 3y squared minus x, so that's these two done. What I'm going to do with these two is I'm going to add y to this side, add y to this side. I'm going to add 18x squared to this side, add 18x squared to this side, add 18x squared to this side. So in other words, what I end up with is y plus 18x squared on this side of the equation. Okay, so now all I've got to do is divide across by this term here in brackets, so let's do that. So on the left hand side I'm just going to end up with, made a just slight mistake here, that should be dy dx. So let's just put a y in here. So here I'm going to be left with dy dx on the left hand side, and on the right hand side y plus 18x squared divided by 3y squared minus x. Okay, so now I have a formula here, if you like, for slope. This is my formula for slope of any tangent at any point xy. Now let's just work out the slope at our particular point. So the point that we're looking at is 1, 2. So x is 1, y is 2. So let's find our slope then. The slope of our tangent then is going to be y, which is 2, plus 18 times x squared, that's going to be 1 squared, all over 3y squared. So it's going to be 3 times 2 squared minus our x, which is 1. Okay, so let's see what we end up with. We end up with 2 plus 18. It's going to give us 20. And here we have 2 squared, which is 4, and 3 fours 12. And we have to subtract 1. So that will give us 20 divided by 11. So there's our slope. We now have a point on our tangent, and we now have the slope of our tangent. So let's just write the equation of our tangent down. So the equation of our tangent is going to be y minus y1 is equal to m times x minus x1. So let's put in our information here. We've got y minus, our y1 is 2. Our slope now is 20 over 11. Our x is x minus our x1 here is 1. There's the equation of our line. So let's just tidy all this up. Okay, so I'm going to multiply across by 11 to get rid of this 11, this fraction here. So 11 times y minus 2 is equal to 20 times x minus 1. That will give me 11y minus 22 is equal to 20x minus 20. Let's tidy all of this up. Let's take these two and we'll bring these two over here. In other words, we'll subtract 11y and add 22 to both sides. So that will give me 0 is equal to 20x minus 11y. And I'll have minus 20 plus 22. That will give me plus 2. So there we go. There's the equation of our tangent at the point 1, 2. So there's two examples of how you would use differentiation to find the equation of a tangent at any particular point.